If you are, yeah, so this, you are now being recorded, so just be aware. So good afternoon, ladies and gentlemen. It's good to meet you virtually for the first time. This is star 121, which is titled Statistical Inference 1. So maybe for the next few weeks, we'll be discussing about statistical inference. I'm sure most of you took the star, is it 114? No, in the first semester. So I hope you also enjoy yourself this time around. So I'm going to share my screen because we don't have the luxury of time. So here is our Google Classroom. Can you confirm if you are able to see my screen?
I can see it, sir.
Excellent. So this is our Google Classroom. I believe most of you have joined the classrooms. So this page is called the stream page, and that's where you always come anytime we have the virtual meeting. So you can join the meeting from here. Then you can also make announcement here freely. You can share opinion. You can even attach links, upload files if you want the class members to benefit from anything, even including adding YouTube videos and other useful resources that you think can benefit the class. I want the class to really be interactive as much as possible. So feel free to ask questions and also answer questions. Here is the classwork page. And here you have resources ranging from assignments. You have 2 assignments that are pending. So you have you have quiz assignment. So so far, I think about 103 have turned in their pre-lecture assignment. I think you have done very well. I'll come back to that. Here we have list of registered students for this course. I think the list has been updated. Maybe later the updated list will also be uploaded. These are useful videos, not necessarily part of the course, but uh, just a minute. Um, sorry. sorry for that. So let's continue with the uh, panorama view of the classroom. So here you have some useful videos that can help you get familiar with R and R Studio environments, do some data manipulations, descriptive. So some of the things, some of the videos you can watch here, they are not meant for the course precisely, but they are also relevant if you want to master statistical practice. Then for the software that will be used is R, and by now I believe most of you should have uploaded that, and you will need it for the class of tomorrow. So if you have not done that, I think you should do that as soon as possible. So here you have all the lecture notes for the course. So we will be taking them one after the other. So today's lecture slides have been uploaded, so you can have access to it here. So let me quickly come back to the quiz assignment. I believe by now you will have seen your score, but the general picture shows that most of you actually did well if you are sincere to yourself. So, which I think will make this lecture to be very, very easy since you have you have reviewed the materials ahead. So I think you should be able to flow easily. So you should be able to ask questions if necessary. So it's the performance here is quite impressive when you have not even, considering the fact that you have not even listened to the lecture. So let's move on straight to what we have today. So these slides have been uploaded, so you can download it in the Google Classroom. Sorry, before I leave that Google Classroom stuff, I wanted to show you the people page. That's where you have uh, the teachers and of course the students. So far we have 139 students in the class, and I'm sure you can see yourself here. You can also see your friend. So it's good that you work together, relate, and I'm not saying you should copy one another, but there are people who will also be working with me. These are postgraduate student PhDs. So in particular, I have Mr. Peter Ohwe. So he will be assisting Mr. Joseph and Harding. So you will see those three people. You can also talk to them. You can ask questions, and they will be helping you in your assignments. So, of course, you won't see this side, but that's where your grades are recorded. So some are already missing their grades. So, but make sure you don't miss any assignment, because the records are automatically secured, so they are saved. Yeah. So let's move on to the lecture proper. So I said for our meeting today, we are going to talk about sampling. And here are the outline. Here is the outline of the topics or subtopics that will be covered. We will have an overview of sampling, and then we'll look at the importance of sampling, look at some terminologies, and so on and so forth. So let's go straight. I'm sure this is not the first time you are hearing about sampling. It's something we all do every day. Even this morning, I'm sure it probably took you some time before you made up your mind what clothes to wear, because you have more than one cloth, so you have to take one. So you have to decide what clothes to wear, and then sometimes also you go to market, you have so many items, but you have to decide which collection of items you will eventually settle for. So sampling is basically selecting. It's all about you selecting a part of a population. So this is, please mute yourself. Don't allow me to mute you. Mute yourself if you are not speaking. Mute yourself. There are people who want to join, so let me quickly add them. So don't, yeah, so let's go back. So when you have a population, so a population, we will define it, but is, okay. Can you mute that guy?
I was shaking. Why is he making me go?
Okay, so Peter, can't you mute those people?
We are no longer co-hosts, sir.
Why? Who remove you? Okay, let me make you one. Only you are a co-host now.
Okay, sir.
And where is Peter?
Prof, I'm also no longer a host.
So I'm going to make you one. So I think you are now. So you should control the class. So let's continue. So you have a population which is, we usually call it the universe, which contains all the items. From this population, you draw a subset. That subset is what we call a sample. So sampling basically is just the process what process did you use to draw this sample from this population? That's just what sampling is all about. So the outcome of this process or the outcome of the sampling is the sample, but the source of the sample is the population. So drawing sample or sampling is something we use a lot in making informed decisions in sciences, businesses, health, even at home. Those who cook, when you prepare your soup, you don't have to lick the entire soup simply because you want to know whether the soup is delicious or not. So you have to just draw a small portion and taste. So sampling is employed even in medical field, in market research. For instance, in medical field, you simply go for blood test and a blood sample is taken. Your entire blood system is the population. But if that entire blood system must be used, then you will not be alive to even hear the result. So that's why sampling is very important in science. And some of the reasons why you just have to sample include the fact that it's economical. The amount you will spend dealing with the population is bigger compared to the amount you will need to spend when you take a subset. In terms of practicability, you can easily attend or cover the sample compared to you covering the population. There are even cases where your population is scattered. It makes it practically difficult to reach every member of that population. Sample, you can be more accurate when you use subset compared to when you use the entire population. When you deal with sample, you can manage your errors, you can control the errors, you can trace the sources of your errors, you can correct those errors much easily compared to when you are dealing with the population. So it saves time and effort, and it's easy to use. But there are also some terminologies that you need to get used to. The first one is census. So when we talk about census, by definition, is the complete count of every individual in that population. So every unit, every individual, every item is covered in the census. But you can have the census, but the population of interest may not be the same as the census. So population itself is the total group of individuals, items, units that you are trying to study. For instance, we can talk about Nigeria. So the census could imply complete enumeration of every individual in Nigeria. But you might be, if you are doing a study, your population could now be population of undergraduate students in Nigerian universities. So you have that as your population. So population is always defined with respect to this subject or to the focus or to the target group, that you want to study. So the subset of the population is the sample. The subset of the population is the sample. And because you are taking sample from the population, you must understand that that sample is now a representative of the population. So, and they cannot be the same. So the difference between, arising, the whatever error that arises because you are taking sample rather than using the entire population is what is called the sampling error. Non-sampling errors, they are not traced to the fact that you have taken sample, but they are traced to the fact that maybe you introduce those errors unconsciously through maybe during your data collection. You are supposed to enter 30, but you enter 300. You are supposed to say your subject is a female, but you mistakenly put the person as a male. So these are errors from data collection. You can also have errors from the processing as well as from the interpretation. So those errors are not due to sampling. They are not because you have taken sample, but they arise because you committed those errors in the course of collecting your data, processing your data, and interpreting your data. So at this point, I would like, if there is any question, you can also put your questions in the chat menu, but I can allow one person to unmute and ask a question if necessary. You will see the icon for raising up hand. You can use it. This is the icon. I'm sure you have it. So if there is no question, then I can continue. The next point we want to discuss is population parameters versus sample statistics. I told you earlier that we take sample from population. Sample is just this, is the subset of the population. So let's say you have the population, just a minute. Let's say you have a population. I want to use the whiteboard to make this clearer. So I believe you can see the board, the whiteboard. So let's say you have this as a population, and this is the sample. You have drawn this, you have taken this sample from this population. So let's assume that you measure some basic characteristics about the population, let's say the mean, and you measure, let's say, the total, and so on. You can also measure variance and all of that. Let's also say that you have come to sample and you compute also the mean from this sample, and you compute also the total. Now, you are not going to, your mean from this population is not going to give you the same value as the mean from the sample. So, and that's what we mean when we say sampling error, because you have taken sample, there will be a deviation, a difference between whatever you obtain from the sample and whatever you have in the population. But we are trying to now talk about the population parameter. So population parameter, they are quantities that you measured from the population. So if I'm interested in the population mean, for instance, then that population mean is considered as a parameter because that mean is measured from the population. So generally, there is a symbol we use, which we call mu. Mu. Now, if I compute the mean also from the sample, well, this will become sample mean. So it's no longer, it's not the same as population mean. So because this is computed from sample, we usually use X bar. So for anything computed from the population, we use symbols, Greek symbols. So for instance, if I compute standard deviation, then I use sigma. If I compute variance, then I use sigma square. So if I compute mean, I use mu. So any quantity measured from the population is usually denoted in terms of using Greek symbols. Any quantity from the sample that we compute, there are sample mean, sample total, and so on. We use letters rather than Greek symbols. So that's what to see here. So if from the population I compute, I'm interested in the mean, so I talk about population mean, then I will denote it mu. The corresponding sample will be X bar. If it's variance, then sigma square. So you notice that population characteristics, when measured, they are represented using Greek letters. N represent the population size, capital N. For the sample, they are mostly represented by letters X, S, and so on and so forth. So the purpose of this, in this lecture, I told you that one issue is we are looking at sampling, and I said basically our concern is how do we draw the sample, how do we draw this sample? This is the population. This is the sample. We are taking this sample from this population. how should we draw this sample? How? That is what we mean by whatever process that we follow to draw this sample from this population is called the sampling. So sampling is a process. And I said earlier, the outcome is the sample and the source of the sample is the population. So what are those methods of drawing sample from the population? So we have the methods are categorized into two. The first, they are called the random sampling methods. These methods are usually preferred. Are you able to admit, Peter?
Yes, Prof. Yes, yes, Prof.
Let me know also if anybody is raising up hand to
Okay, sir.
questions. You can also put your question in the chat menu. Obioma, are you raising up? Your hand is.
Yes, Obioma is okay.
Obioma, can I hear you? You can unmute and let me hear you. I can't hear you. So maybe you can type your question to save time. So let's move on now. So these are methods for random sampling. These are methods for non-random sampling methods. The difference between random and non-random is simply that in random, every member of the population is given equal chance. So if you have in that population, you have Tolu, you have Yemi, you have Akin, you have Biola, and then you are taking sample of 2. Then every member of this population must be given equal chance. You will not say you want only females. When you say you want only females, then you are no longer giving everybody equal chance. You are not going to say you want educated people. When you put that, then it's no longer random. You are not giving everybody equal chance. So what separates random sampling methods from non-random sampling methods is that is random, they all have equal chance. Nobody is discriminated upon. So every member of the population is treated equally. But in non-random, then you can discriminate. You can impose criteria. You can also use your judgment. You can also select based on convenience or whatever. So that's the. But let's quickly now take each of these methods and see how we can implement them. So the first one, the simple random sampling, is the easiest to possibly apply. So each member of the population will be given equal chance of being included in the sample. So we are not going to say, is she a female, is she a male, whatever. So everybody is given equal chance in the selection. So the first step in this place is some people are talking. Some people are talking. Can you mute them, Peter? Yeah. So
they are muted, sir.
Thank you. The first step when you want to implement simple random sampling is to define the population. You must define, you must know the characteristics of the population. For instance, are you interested in undergraduates? Are you interested in vehicles with Oyo State plate numbers? Are you interested in smokers only? So anybody who is not a smoker will not be part of your population. Are you interested only in animals with 4 legs? Are you interested only in animals that are flying? So you define the population, and that must be the first thing, so that you know those who should belong to that population and those who should not belong to that population. The second thing is to create a sampling frame. A sampling frame is just a list. So sampling frame is just a list of the members. So you must list them: number 1, member of the population; number 2, number 3, number 4, number 5. If there are 1 million, you must list all of them. So a typical example is even our classroom. Okay, sorry. Let me give you another example. Yes. So this is I'm looking for, yeah, let me go to our classroom. We have the student list there. So I can open it. So for instance, this is our classroom. So the list of registered students in this class. So we have this. So this can be considered as a frame. Any list containing the members, the members of the population is called a frame. So once you define the population, then the next thing, of course, is to create this list and then call it your sampling frame. So it is from this, after you have created the frame, you now determine how many sample do you want. No, what is your sample size? For instance, in our case, we have about 157. So how many do you want to select? Are we selecting 10%, 20%, or is there any specific number that we want to select? Later in the course, we will see how we can select the criteria, the formula for selecting the sample size, determining the sample size. That will be discussed later. But for now, you have to decide what should be your sample size. So then, of course, you will now select them randomly. So like the example here, you have T, you have Y, you have A. Let's say you also have K, you have M. Let's say these are people, and you now want to select only 2 for your sample. So the first thing is to list them, to create a list. So number 1, T; number 2, Y; number 3, A; number 4, M; number 5, B; number 6, K. And now that you have created the list, you will now select them randomly. So one way to select is to use lottery method. So maybe you put each of them in paper, and then you squeeze the paper, shuffle the something, and then select the two randomly. That's one way. You can also use the table of random numbers, generate table of random numbers. If you go online, you can say generate random number. So you can easily generate random numbers. Maybe you want a number between 1 and 10, like in our case now. So we can simply generate, this is 3 is selected. So which means I'm going to select number 3. So if I go back and I generate again, 2 is selected, so which means number 2 will be selected. So since I want only 2, I've used the random number generator to select those 2. So you can also use softwares, and we are going to demonstrate that later. So there are different ways by which you can generate your sample and draw the sample. So you can now collect data from the selected sample members, and then you analyze and draw your inference. That's simple random sampling. Then stratified random sampling is used where the population is made up of distinct groups. So if you have a population that is, let's say you have a population that is made up of distinct groups. Let's say this is the population, and there are in this group different categories that they don't overlap. Maybe these are you categorize them based on socioeconomic status, or maybe the those who, whatever criteria you want to use. So you can say this is low income earners, middle income earners, upper income earners. Then these days you have the poor of the poorest of the poor. So you have the poorest of the poor, and so on like that. So you categorize your population, or the population is characterized by different distinct groups. So in that case, you can use the stratified sampling method. So the first thing is to divide the population into those distinct strata based on the characteristics. So for instance, it could be by age. What I've done here could be by age. Maybe this group represent those below 5 years, those below 10 years, those below 18 years, those below 25, those above 25. So, but each group like this is called stratum. Stratum is the singular of strata. So here we have 1, 2, 3, 4, 5 strata. But you have each group or each stratum is different from another stratum. So the population is heterogeneous, but within each stratum, members are homogeneous. So you determine the strata size. So in other words, what is the size of this stratum? What is the size of this stratum, what is the size, so you determine what the size of each stratum is. And then once you determine that size, then you randomly, you will now use the method we use, the simple random method, to now select, you follow the same procedure that we use in the simple random to now select the sample from each stratum. So in essence, you will have sample from this group, you have sample from this group, you have sample from this group, you have sample from this group, and so on. So each group will have a representative in your final sample. That's the beauty of stratified sampling, because it takes care of the groups within the population. Now, after you have selected them, you can now collect your data and then combine the samples, run your analysis. The other type of sampling, which is also random sampling method, is the cluster sampling. So in the cluster sampling, the population is also divided. It's also divided sometimes based on geographical consideration, using boundaries and so on. So, but rather than calling each group now a stratum, we call it cluster. So this could be cluster 1, this will be cluster 2, this will be cluster 3, and so on. So you divide the population into clusters. So the difference now is that you are selecting, let's say here we have cluster 3, 4, 5, 6, 7. So in cluster sampling, you are selecting among the clusters. So I only need to select, if I'm interested in only 2 clusters, then I'm selecting only 2. Let's say I select 5 and I select 1. So, which means I'm taking 2 clusters out of 7 clusters. This is different from stratified. In stratified, from each stratum, you are taking sample. But in cluster, you are only selecting among the clusters. So take note of that. So once you have selected the clusters, and then you can now go on collect your data. Of course, you have to collect data from all units, all members in the selected clusters. You have to collect data. So all the members here will participate. You have to collect information from all of them. Same thing with here. So you are not going to select members from all the clusters, but you are selecting clusters and collecting data from all units within the selected clusters. Then the next one is the systematic sampling. So the systematic sampling, you have to order the population, which means you have to arrange the population in either alphabetical order or in geographical order. And then let me give you an example, like the one we did here. So we have T, let's say I arrange them, Y, A, M, B, and then K. So this represents so this is number 1, number 2, number 3, number 4, number 5, number 6. Excuse me. So after you have ordered the population like that, then you have to determine what we call the sampling interval. So the sampling interval is usually the population size divided by the sample size. So remember that my plan here was to select 2. So that's my sample size. And remember here, there are 6 members in the population. That's the population size, which is 6. So therefore, my sampling interval is the population size divided by the sample size. So that is what this line is saying, population size divided by the sample size. So here that gives me what? That gives me 6 divided by 2, which is equals to 3. So my sampling interval is 3. So what that means is that I can now randomly select the starting point, which means between 1 and 6, I can choose anyone randomly. So let's go back. Between this and this, I can choose anyone randomly. And if I want to be objective, I'll go back to my random number generator and simply put the maximum here to be 6. And then I can now generate. So number 6 is choosing in this case. So I come here. So I'll come now and then select number 6. So which means out of the 2 I want, I'm going to select number 6. Then the next step is after you have selected the starting interval, after you have chosen the starting point, then you will now select at regular intervals. This time, that will be because our interval is 3. Our interval is 3. So I'm supposed to now count, since let's say we have 7, 8, 9, then I'm supposed to now count the 3, and select the third one. So 1, 2, 3.
Hello,
But,
Prof.
hello.
Someone has a question. If you're
I'm coming. Let me finish this.
Okay, sir.
So, but since this is the end, then I will have to start from the beginning. So, which means I will have to start from 1, 2, 3, which means this will be the next selection. So, in this case, my sample will simply be A and K. So, this is systematic sampling. In systematic sampling, you need to know the sample size, you need to know the population size, then you need to compute the sample interval, and then you simply you compute the sample interval by dividing the population size divided by the sample size, and that gives you the sample interval. And then that represents the interval within which you select subsequent member of the sample. Yes. Who is
Prof, there are
start
three.
there?
There are 3 people, sir.
Yes, if they can make it quick, our time is almost up.
Okay, maybe Trisha should go first. Trisha. Okay. Since Trisha is not speaking, Ifeoluwa. Star girl.
Okay, I think
Okay. Ifeoluwa put a question.
Ifeoluwa seem to have typed a question. Please, if we are to order or arrange a data according to their score in an examination, and we have 2 or 3 scores that are the same, please, with the 3 or 2 score, take the same position or follow one another. In this discussion, we are not talking about scores, but we are talking about individuals, about items, not measurements. So your question, of course, it applies in another situation, but not in this context, Ifeoluwa. So 2 people can never occupy the same position if we are ordering them. So you have to, if I'm to arrange the class, so I can, you can be the first, another person will be the second, but 2 of you will not be arranged to occupy one position, the same position. So I understand your question, but it doesn't apply to this context. Is there any other question? I believe you don't have a lecture now. I might still be able to use 30 minutes of your time. This being recorded. If you have lecture, let me know. But you can also, you will have access to the recorded video thereafter. So let's quickly finish up. So that's about the systematic sampling. In the multi-stage sampling, or why is it that people are not able to talk? Is it that they cannot unmute?
Sir, we can talk, sir.
Okay, why is it that people
We
are
can
not?
talk, sir.
Okay, do you want us to continue a little bit more?
Yes, sir.
Okay,
No,
I
sir.
hope. Who is saying no? What is the problem? What is the problem? What is the problem? So if you say, I'm going to, okay, you have another lecture. Okay, fine. So I will stop the lecture now. And I think that will be the first thing we will do tomorrow. Yes.
Okay, sir.
So I'll stop now
Thanks, sir.
and then we'll continue from there tomorrow. Enjoy the rest of your day.
You too, sir.
Sir. Thank you, sir.
Thank you,
Goodbye,
sir.
sir.
Thank you,
Sir,
sir.
I have a question. Thank you, sir.
Go on, let me stop recording, then you can ask. If you don't have lecture, you can wait a little bit, ask your questions.